Hello, everybody, and welcome to the South Florida Power BI user group. I am Adriano, and I'm your host. Thank you very much for joining us here today and taking time of your day to make us part of your learning experience. Today, I have Nicola Illich. Hello, Nicola.
Hi, Adriano. Hi.
And thank you very much for joining us here. We thank you for the time to prepare and to you're making here to share with us your knowledge. We really appreciate that.
Thanks for having me. Thanks for inviting me. It's a pleasure always to share the knowledge and to presenting for South Florida Power BI user group.
Thank you
Thank you.
very much. We all appreciate that. And folks, thank you all here. I see that we have, look at that, we have some of the attendees from, I just saw here, from Romania. I see there Christian. Hi, Christian. Thanks for joining us. And folks, take a minute, use the chat to post your comments as well as questions here. And to do that, all you have to do is to subscribe. So please take a minute, subscribe to the channel, like the video, and also comment on the video. This will be a fantastic presentation here. And today, what we'll be talking about is the Power BI reducing model size by 90%, presented by yours truly here, Nicola Illich. And just before we start, just a couple things I would like to remind you is to, if you have a topic you'd like to know more, also check the comment section and you will see our meetup user group. And on that, all you have to do is to join the group and drop me a message, and we will do the best here to get to you on the topics that you're looking for. We would appreciate that. All right, and let's get back to our guest here, Nicola. So tell us, Nicola, how are you doing first of all, and where you at?
Thanks for asking. Yeah, all good at my side. I'm currently in Austria, in Salzburg. So our summer is gone and we already got snow here in mountains close to Salzburg. So I suppose it's better at your part there, but other than that, all is good. Hope it's the same on your side.
It's all good. Well, it's all good here, barring the current pandemic conditions, but the weather is definitely a great one. We're very fortunate not to be, how can I say, have snow here. At, so that is a good thing. I'm more of a person from the tropics.
Yeah, I guess so, yeah.
All right. And tell me a bit about the session that we are going to be seeing today, please.
Well, the idea for this session came out after last year. I had a situation during my regular job. We had a problem with the Power BI file size on our reporting server. Before I explain in details, we are using Power BI Desktop for reporting server, so on-premises solution, and the file size was growing, on a daily basis, because someone who created the report maybe 3 years ago, 2-3 years ago, it was, not so much data in it, and someone, assumed that it will not be a problem if all data comes into a Power BI file. But logically after some time and after data volume grown, we faced this problem, and I was one of the guys who were involved in trying to find a solution. So I will show you how we solved this and how we reduce data model size really. So it's not a click byte or something. It's really 90%. I will show you in a demo how we managed to reduce data model size really by 90%.
Very interesting, and I'm quite sure this is a problem and a challenge that many of us do face. And
Sorry, Adriano, I can't hear you.
I'm sure that this is great information, because this is a type of issue that we all come about, and this will provide us the steps, and I know that in your presentations will be very detailed on the approach and implementation of it.
Sure. That's the reason why I wanted to share our experience, my experience regarding this topic, because I'm sure that all of us are facing similar challenges, during your job or whatever.
Absolutely. All right, folks. Without further ado, let's get started. And now it's all you here, Nicola.
Okay. Thank you, Adriano. Thank you all guys for joining. I will share my screen now. Hope that you can see my screen. Okay, then we are good to go. So again, hi everybody, good afternoon or good evening. Hope you are doing all fine. And once again, thanks Adriano for inviting me, for having me today. It's really a pleasure, as I said, to present for South Florida Power BI user group. Last month, I was talking here about some cool tips and tricks related to Power BI visualizations. And today we will spend some time learning about the Power BI internals. I believe it's a quite important topic from many perspectives. Therefore, I really hope that you will enjoy the session and get some useful takeaways once we are done. Okay, before we start, let me just briefly introduce myself. My name is Nikola Ilic. I'm originally from Belgrade in Serbia, but since last 4 years, I live in a wonderful city of Salzburg in Austria, where I work as a business intelligence developer at company ITSP Services. Living in Salzburg was the reason why I've chosen my nickname Data Mozart, as Salzburg is probably you all know worldly known as the birthplace of Wolfgang Amadeus Mozart, and I was therefore brave enough to use his last name as part of my nickname. And that's why my motto is make music from your data. I'm regularly blogging at data-mozart.com. I'm also pretty active on Twitter and LinkedIn, so feel free to ping me or connect if you like. A few more sentences about me. I have multiple year experience working with different data products, predominantly with Microsoft Data Platform. Started with SQL Server, then brushed myself with analysis services, multidimensional reporting services, integration services, and the last 3.5 years with Power BI, which I'm a big fan of. I'm also a Microsoft certified trainer and certified data analyst. Privately, I'm a father of 2 little kids, and through football and Barca fun, as you can conclude looking at the photo on this slide. Prerequisites, well, this is a 300 level session, which means advanced level. So it assumes that you have some, not just basic, but I would say intermediate knowledge and experience with Power BI and data modeling in general. That being said, I expect from you to have at least basic knowledge about relational databases in terms of how the data is being stored in the database, and to be able to distinguish, let's say, between rows and columns for the starter. Of course, understanding of Power BI is also necessary, because I will often refer to some things related to Power BI development that I assume you are familiar with. Quick intro into agenda. We will learn what is VertiPack, how it stores the data, what kind of algorithms VertiPack applies to compress the data, and how we can help VertiPack to build an optimal data model for us. This is going to be a theoretical introduction for our demo. And yeah, we will get our hands dirty and dig deep under the hood of Power BI. During this demo, as I mentioned in the beginning, I will show you on a real-life example how I managed to reduce Power BI data model by unbelievable 90% just by sticking with few rules that we will talk about today. So here we are. What is VertiPack? Before I start talking about VertiPack, I would like to ask you one question. Have you ever wondered what makes Power BI so fast and powerful when it comes to performance? It's so powerful that it performs complex calculations over millions or even billions of rows in a blink of eye. As I probably already mentioned, today we will dig deep to discover what is under the hood of Power BI, how your data is being stored, compressed, queried, and finally brought back to your report. And once we are done, I hope that you will get a better understanding of the hard work happening in the background and appreciate the importance of creating an optimal data model in order to get maximum performance from the Power BI engine. So before I answer to the question, what is a VertiPack? We should mark the line between row store versus columnar databases. VertiPack is a columnar database. As you can see in this illustration, columnar databases stores and compresses data in a different way to traditional row store databases. Columnar databases are optimized for vertical data scanning. And that means that every column is structured in its own way and is physically separated from the other columns. Another important distinction in order to understand what is VertiPack is to understand the difference between Formula Engine and Storage Engine. In this illustration taken from the book Definitive Guide to DAX by Marco Russo and Alberto Ferrari, you can see how this looks behind the scenes. So Formula Engine accepts the request, processes it, generates the query plan, and finally executes it. Storage Engine pulls data out of tabular model to satisfy the request issued within the query generated by the Formula Engine. Storage Engine works in two different ways in order to retrieve requested data. So here you can see the thing we will talk about most today. So it's a VertiPack. VertiPack keeps the snapshot of the data in memory, so in our cache memory. And this snapshot of data can be refreshed from time to time from the original data source. On the other side, Direct Query doesn't store any data. It just forwards the query straight to the data source for every single request. So Formula Engine, as I already stressed, Formula Engine is a brain of Power BI. It accepts the query, and since it's able to understand DAX and MDX also, but it is out of the scope of this session, it translates DAX into a specific query plan consisting of physical operations that need to be executed in order to get our results back. Those physical operations can be joins between multiple tables, filtering, or aggregations. It's important to know that Formula Engine works in a single-threaded way, which means that requests to a storage engine are always being sent sequentially. So let's reiterate once more through the whole process within Formula Engine. So the first step is that Formula Engine accepts the request. Then it will process this request. Next in the line is generating the plan for the request. And finally, it executes the generated query. Storage Engine is the muscles of Power BI. And once the query been generated and executed by the Formula Engine, then storage Engine comes into the scene. It physically goes through the data stored within the tabular model, which is a VertiPack, or goes directly to a different data source like SQL Server database, for example, if you are working with direct query storage mode. When it comes to specifying the storage engine for the specific table, there are three possible options to choose from. First one is in import mode, then direct query, and finally dual mode. And as opposed to a Formula Engine that doesn't support parallelism, Storage Engine can work asynchronously. Import mode, which is the most used one in Power BI, it's based on VertiPack, and table data is being stored in memory as a snapshot. As I already said, data can be refreshed periodically depending on your business needs. Direct query data is being retrieved from the data source at the query time, and data resides in its original source before, during, and after the query execution. Finally, dual mode is a combination of previous two, so combination of import mode and direct query mode. It works in that way that data from the table is being loaded into memory, but at the query time, it could be also retrieved directly from the source. Let's now talk about import mode more in depth. As you've drawn a big picture previously, let me explain now in more details what VertiPack does in the background to boost performance of our Power BI reports. So when we choose import mode for our Power BI tables, VertiPack performs the following actions. It reads the data source and transforms data into a columnar structure, like we saw in this first illustration during the session. Then it encodes and compresses data within each of those columns. After that, it establishes dictionary and index for each of the columns. After that, it will prepare and establish relationships. And finally, it will compute all calculated columns and calculated tables and compress them. So how VertiPack stores the data? Two main characteristics of VertiPack are that it is a columnar and in-memory database, as I already stressed previously. So VertiPack applies different types of compression to each of the columns independently, choosing the optimal compression algorithm based on the values in that specific column. Compression is being achieved by encoding the values within the column. But before we dive deeper into a detailed overview of all encoding techniques, just keep in mind that this architecture is not exclusively related to Power BI. In the background is a tabular model, which is also under the hood of Analysis Services Tabular and Excel Power Pivot. Let's now examine the encoding types which VertiPack applies in order to compress the data. So first one is a value encoding, then hash encoding or dictionary encoding, and finally run length encoding or RLE. We will walk through each of these encoding types in more detail. So value encoding is the most desirable value encoding types since it works exclusively with integers and therefore require less memory than, for example, when working with text values. How does this look in reality? Let's say we have a column containing a number of phone calls per day. Let me zoom it a little bit. I'm not sure if you're seeing everything fine. So let's say we have a column containing a number of phone calls per day, and the value in this column varies from 4,000 to 5,000. What the VertiPack would do is to find the minimum value in this range, which is 4,000 in our example, and set this minimum value as a starting point. Then it will calculate the difference between this value and all the other values in the column, storing this difference as a new value. What's the point here? So as you can see in our example, we saved 3 bits per one row. And at first glance, 3 bits per value might not look like a significant saving. But if you multiply this by millions or even billions of rows, I think you will appreciate the amount of memory saved by using this kind of encoding. Hash encoding is probably the most used compression type by VertiPack. Using hash encoding, VertiPack creates a dictionary of distinct values within one column and afterward replaces real values with index values from the dictionary. As you may notice in this illustration, VertiPack identified, let me just zoom it again. So VertiPack identified distinct values within the subject column, so here. Built a dictionary by assigning indexes to those values. You can see that, for example, for complaint is 0 and everywhere is 0. And finally stored these index values as pointers to real values. I assume you are aware that integer values require way less memory space than text, so that's the logic behind this type of data compression. Additionally, by being able to build a dictionary for literally any data type, VertiPack is practically data type independent. This brings us to another key takeaway. So no matter if your column is of text or big integer or float data type, from VertiPack perspective, it's all the same. It needs to create a dictionary for each of those columns, which implies that all these columns will provide exactly the same performance, both in terms of speed and memory space allocated. Of course, by assuming that there are no big differences between dictionary sizes within those columns. So it's a myth that the data type of the column affects its size within the data model. It just affects the dictionary size. The main factor that affects size of the column within data model is cardinality, so number of distinct values within the column, and it mostly influences column memory consumption. Run length encoding creates kind of a mapping table containing ranges of repeating values, avoiding that way to store every single repeated value separately. Again, let's take a look at example it will help to better understand this concept. So in real life, VertiPack will not store date start values, so it will not store this column. This is just for the sake of clarity here, but in reality, VertiPack can quickly calculate where the next node begins just by summing previous count values. As powerful as it might look at first glance, run length encoding algorithm is highly dependent on the ordering within the column. So if the data is stored the way you see in our example, I will show you here. So with a lot of repeating values, so data is kind of buckets here. Run length encoding will perform great. However, if your data buckets are smaller and rotate more frequently, then run length encoding will not be an optimal solution. And one more thing to keep in mind regarding run length encoding, in reality, VertiPack doesn't store the data this way. So first it performs hash encoding and creates a dictionary of the subjects, and then it will apply run length encoding. So the final logic in its most simplified way would be something like this. So it's important to remember that run length encoding occurs after value or hash encoding in those situations when VertiPack thinks that it makes sense to compress data additionally. So when data is ordered in that way, that run length encoding algorithm would achieve better compression than only hash encoding. Let me just briefly iterate through the process of data compression for a specific column. So VertiPack will first scan a sample of rows from the column, and if the column data type is not an integer, it will look no further and it will use hash encoding. On the other side, if the column data type is integer, some additional parameters are being evaluated. If the numbers in this sample linearly increase, VertiPack is smart enough to assume that it is probably a primary key, and it will choose to perform value encoding. On the other side, if we have a value range within our integer column, and those values are reasonably close to each other, so like in our example with phone calls per day, 4,000 to 5,000, VertiPack will use value encoding. On the contrary, when values fluctuate significantly within this range, for example, between 1,000 and 1 million, then value encoding doesn't make sense and VertiPack will apply the hash algorithm. However, no matter how smart VertiPack is, it can also make some bad decisions based on incorrect assumptions. Therefore, sometimes it can happen that VertiPack makes a decision about which algorithm to use based on the sample data, but then some outlier pops up and it needs to re-encode the column from scratch. So let's use our previous example for the number of phone calls. And let's say that VertiPack scans the sample of rows and chooses to apply value encoding. Then after processing 10 million rows, all of a sudden it finds 500,000 value. It can be an error or whatever. Now VertiPack will need to reevaluate the choice of value encoding, and it can decide to re-encode the column using the hash algorithm instead. So it will do this from the scratch. Surely that would impact the whole process in terms of time needed for reprocessing. Here is the list of parameters in order of their importance that VertiPack considers when choosing which algorithm to use. First one, as already mentioned, is the number of distinct values in the column, or that's called cardinality. Then data distribution in the column, which means that column with many repeating values can be better compressed than one containing frequently changing values, because as you learned, run length encoding can be applied on the top after hash encoding. Then the number of rows in the table, And finally, column data type, which impacts only dictionary size, not column size itself. Okay, I believe we laid a solid theoretical background for the things that come now. So it's time to get our hands dirty and see how all of this work in reality. So this demo, for all of you who came later, I explained in the beginning of the session, but let me just reiterate once more. So this demo is based on a real use case which I faced during the last year. The problem was with the size of PBIX file on our report server, as file size dramatically grown since the report had been introduced first time, and I was involved in trying to find a solution. Okay, so I slightly simplified the data model here. I will show you now. I'm in my Power BI desktop. So I have fact chat table as a central table in my data model. I removed few dimension tables, left just these two, dim country and dim product. And if I go to a table, sorry. Yeah, sure. Sorry. Let me zoom it a little bit. So I have fact chat table, which is a central table in my data model. And I have two dimension tables for products and countries. So this is simple data model. And I will now show you for fact chat table, we have around 9.3 million rows. So here you can see that we have around 9.3 million rows. That's nothing special in terms of volume. I mean, Power BI should be able to cope with that without any problems. But the problem is that all tables were imported in Power BI as it is, without any additional optimization or transformation. So just simple checking the table name and import mode, that's it. And I see many people do like do this, just selecting the whole table and put everything in data model. So to be able to follow what is going on with our data model, I will use DAX Studio. For those of you who are not familiar, DAX Studio is a fantastic free tool created by Darren Gosbell, Marco Russo, and Alberto Ferrari. It has a whole bunch of very handy and useful features that I would really need another 60-minute session dedicated just to it. So in any case, if you are working with Power BI on a day-to-day basis, you should definitely start using DAX Studio. Believe me, it will make your life much easier and it will boost your productivity. So let's go to external tools and go to DAX Studio directly from this Power BI file. Okay, so before I show you what's happening here, one small digression. I want to show you something. Here is our Power BI file. Just remember this number. So this is the memory footprint of our PBIX file. It's 770 megabytes. Okay, so remember, just keep in mind this number. Okay, so I lied to you. That's not the whole truth. The truth is even worse. So it's not just 770 megabytes, it's even more. And I will show you now how can you check the whole data model size. Once you are in DAX Studio, go to Advanced tab and click on View Metrics. So this is the Vertipec Analyzer tool, one of my favorite tools within DAX Studio. Once I click on View Metrics, it will load my data model here, and I can see different kind of metrics for my data model. So let's quickly walk through some of the most important. So here on the left side, here you can see all tables from your data model, and here you have different metrics for all of your tables. You can see what is the cardinality, you can see the column size, and you can see the dictionary size, encoding types, etc., and how much percentage each of those tables occupy in your data model. If I click on Summary here, on Summary tab, I can see that complete data model size is 1.86 gigabytes. So it's even worse. It's not 770 megabytes, it's 1.86 gigabytes. Why is that? Because memory consumption is being calculated taking into account following factors. It's PBIX file, of course, then dictionary. I talked about dictionary previously while explaining hash encoding, then column hierarchies, user-defined hierarchies, and finally relationships. So we can see all of this here in VertiPaq Analyzer. Okay, so that really hurts, and we haven't even interacted with our report. So let's see what we can do to optimize our data model. I will expand the most expensive table, which is effect chat, and now I can see data for specific tables within my specific columns within my data within my table. Sorry. And I can see that the most expensive columns are these date time columns, date TM start UTC, then source ID, and etc. etc. Here I can see which kind of algorithm VertiPaq used to compress the values. So these are hash and value encoding types. You learned about them in previous part of the session. So let me check what can be done here in order to optimize the data model. First, I see here chat ID column, which is just a surrogate key from my data warehouse, and source ID, which is a primary key from the source system. So do I need both of them? Definitely not. So let's get rid of the one which is more expensive, and that's source ID column. You see that all these numbers, I forgot to mention, all these numbers are in bytes. So this source ID column in total takes 340 megabytes. So let's go back to Power BI desktop. I'm going to transform data. And once I'm here, okay, I will remove my source ID column. Okay, remove. I hit close and apply. And let's check if that brought some benefit to us. Okay, going back to DAX Studio, again, view metrics. And now when I go to summary, I can see that my data model size is 1.54 gigabytes. So just by removing this one single column, we reduced our data model size by 300 megabytes. Okay, so let's go back and check if some other columns can be removed. Another thing, do we really need here date TM start, which is original time zone when chat started, and date TM start UTC? I mean, we can, for example, preserve UTC times, and then if we need to calculate some specific time zones, we can do that later in Power BI directly using DAX or Power Query, but we don't need both columns imported in our data model. Also, session referer and referer columns. So let me just sort by percentage. Session referer, let me just zoom it. These two, session referer and referer columns, are both very expensive. They have high cardinality, so more than 1 million. And the dictionary size is extremely high, especially for session referer. So 280 megabytes, only dictionary size. What I did next here, so I asked my users if they need those columns, and I got confirmation that they don't need it for any kind of analysis, and they really were not used in any kind of calculations. So why on earth should we bloat our data model with them? Also, this column, I'll show you last edit date. Let me zoom it. Last edit date, it's just the date and time when the record was last time edited in the data warehouse. Again, I checked with my report users, and they didn't even know that this column exists. Chat variables, another column, very expensive. That column holds data about some background stuff from the application, so not used in any kind of analysis, not used for any kind of calculations. Let me show you shortly. So if I go to fact chat and chat variables. So it's, as you can see, some generic stuff, some JSON records, so they don't need it. So I can freely remove all of those columns. And let's see if that can bring some benefit to us. I mean, it will obviously bring, but let's see what kind of benefit. So I'm going to okay, so to remove columns, and let's go remove date TM start. We don't need it. Then the next one is the referer, session referer also. Next one was last edit date, yeah, and chat variables. So I will remove all of those columns. Okay, they are removed. Close and apply. Now Power BI will need some time to create another connection and to apply all changes to our underlying data model. It was pretty fast. So let's go again to view metrics. And now when I go to summary, it's 660 megabytes. So it's just by removing few unnecessary columns, we reduced our data model size by 2/3. So that's unbelievable. And truth to be said, if you go to fact chat table again, there are some other candidates also for removal from this table, some other columns which are not being used. But yeah, let's focus now on some other techniques for data model optimization. Okay, so let's see what are the most expensive columns in terms of cardinality. So not size they occupy, but cardinality. The most expensive one is date TM start UTC, okay, and our chat ID column. So chat ID, even it has a higher cardinality than date TM start. Let me zoom it a little bit. So it has higher cardinality, but because Vertipack applied value encoding here, you can see the dictionary size is irrelevant. It's 120 bytes. On the other hand, dictionary size for the date time column is extremely high, so 357 megabytes. So the rule of thumb is the higher the cardinality of a column, the more distinct values in it. It's harder for Vertipack to optimally compress the data, especially if we are not working with integer values, as you can spot here. So there are multiple techniques for reducing the column cardinality, such as splitting columns, and I will share with you now a few examples of using this technique. Let's go back to a presentation. First one is using division and modulo operations. Let me zoom it here. So I wrote a simple T-SQL code, which will split my chat ID column into different columns. The first one is using divide operation, and the second one using modulo operation. And as you can see, we reduce cardinality here. Instead of having cardinality 19, because of 19 rows you see in this example. So all of these records were distinct values. Now we have here cardinality of 2 in chat ID div column. We have cardinality of 2, so only 2 distinct values, 1794 and 1792. And here we have distinct values, but they are growing sequentially, so Vertipack can apply value encoding for this column. So that was the first technique. The other one is splitting. If you work with decimal values, you can split your column before and after decimal point. In this example, you see that here we have 8 distinct values, so cardinality of 8. If we split these to 2 columns, here we have cardinality of 2, and here we have also lower cardinality, and the values are closer to each other. So there is a big chance that Vertipack can apply value encoding. Finally, if you work with date time columns, you can split date time column to date and time separately. You do this by just writing some simple T-SQL T-SQL syntax, and here you can see that we split these. Basically, we reduce the cardinality by splitting this to date and to time. If you use this technique, the worst case scenario for time column is 886,400 distinct values. That's the number of seconds within one day. So you can't have higher cardinality than that for the time column. Or for date column, it depends on the number of records and the period you include in your column. Okay, so that was this. Let me go back to Power BI Desktop. Just to mention that these techniques, of course, they bring benefit in terms of reducing data model size, but they require additional effort in the report itself because you need to rewrite your measures to return correct results. So be careful when to use them. We will examine this in the closing part of the session. I just wanted you to be aware that these techniques exist and can bring significant benefits in some specific scenarios. Since we don't have any decimal values, let's focus on our problem optimizing date time column. So this date TM start UTC column. The first thing is to check if my users need granularity higher than day level. So in most cases, in 90% of requirements, day level granularity is completely fine. But yeah, you shouldn't, in any case, you should check with your users what kind of detail, what level of detail they need. Okay, so if I go and change this to a date, so I'm going to transform data. I prepare different Power BI desktop files just not to spend too much time waiting for all changes to be applied to our data model. So here you can see that I did exactly the same steps as in the previous file. I just switched the type here. So from date time, I switched to date. So I eliminated hours, minutes, and seconds. Okay, and if I go to DAX Studio to check what is the size of this data model, so going to Advanced View Metrics, and let me expand it a little bit, go to Summary, it's 213 megabytes. So we are already at 90% savings, but we are not done. So 213 megabytes, that's huge, that's a really huge saving. However, it appeared that day level grain was not fine for my users and they needed to analyze figures on hour level. Okay, so we can at least get rid of minutes and seconds, and that would also decrease the cardinality of our column. So what I did there, so going to transform data, and here I needed to write a T-SQL query to retrieve the data. So instead of importing columns, I wrote the T-SQL here. Let me just put it somewhere so you can see it. I will show you what does it do. Okay, I hope you can see it now. Okay, so here we are using datetm built-in T-SQL function to round datetm start to an hour level. So basically all chats which started between let's say 1 hour 0 minutes 0 seconds and 1 hour 59 minutes 59 seconds will be rounded to 1 a.m. or 1 p.m. whatever. Okay, so that's the logic to round all the chats to an hour level. Okay, and if I do this and hit close and apply, let's go again to DAX Studio and check the size of this model. Okay, going to Advanced View Metrics. And now it's 221 megabytes. So if I compare it with the previous one, so it here was 213 and here is 221. So we have 8 megabytes more, but we fulfill the request of our users, so we are still good. And yeah, so another thing here which I wanted to emphasize is, if you take a look here, you see this local date table with some weird characters after that local date table. So what's this? These are automatically created date tables in the background because we didn't turn off our auto date time option for data loading. So that's another handy use case of DAX Studio, because you can't see these hidden date tables anywhere in Power BI Desktop. But once you connect your data model to DAX Studio, you can see them here on the left. Okay, so going back to our original problem, how can we optimize our data model additionally? So let's open this last one and see what we have now. So the one thing that bothered me here still is this chat ID column, because it has really high cardinality, and it wasn't used anywhere in our calculations in the relationships. That's just a surrogate key. So you can't simply remove all these ID columns. For example, this IP address ID, this customer ID, user ID, country ID, product ID. Those are all foreign keys to our dimension tables. In our example, we don't have these dimension tables. I removed them, but we have dimension product and dimension country. So I can't simply remove all these ID columns and my problem is gone. No, but there are ID columns. So there are key columns that you can freely remove from data model because they are not part of any relationship and they are just bloating your data model. So I was here examining two different solutions. The first was to simply remove the column and aggregate number of chats, counting them using group by clause. I will show you now this first solution. So if I go to transform data, again, I used T-SQL query for getting my data to Power BI. Okay, going to show you here. Okay, so what do we have here? Here, I just, oops, I'll zoom it. I just grouped my chat IDs based on all other attributes and using group by column. So basically, I was aggregating this value and this way reducing cardinality. Let me show you this. Here we have cardinality of 9 million or 9.3 million cardinality. Now, when I aggregated this, just close this. Okay, and when I open DAX Studio for this data model, for this intermediate step, again going to advanced view metrics and going to fact chat, I can see now that my chat ID column, look at this, it has cardinality of 13. So it's not even worth mentioning anymore. Just to show you, to compare the previous one. So here is 9.3 million and here is 13. So that's the huge difference. That's really huge difference. But in the end, as I already mentioned, I find out that this chat ID column is not being used at all. So I decided to remove it from the data model completely. And once I did that, I will show you now. So it's been completely removed. And you can see here that I'm only using this, as already mentioned, the T-SQL function for rounding times to a closest hour, and all the other attributes as in my original Power BI desktop file. Okay, so let's check this one. Going to external tools, DAX Studio. Okay, going to advanced view metrics. And now when I go to summary, it's 161 megabytes. So 161 megabytes. I also forgot to do one more thing to disable this auto date time option. You're doing this, but by going to a file, then choosing options and settings, going to options. I mean, this is really annoying feature because by default it's enabled. So you need to disable here in time intelligence, just disable this auto date time. Okay, when I did this, I forgot to mention that I put only one visual in all of these Power BI desktop files, so you can follow up and see that my results are still correct. Despite all of these changes, my results are still valid. So once I remove those auto-date columns, let's go again to Power BI desktop, view metrics, and it's okay. We saved 4 megabytes, additional 4 megabytes, and my data model size. Just please recall the number where we started. It was 1.86 gigs, and now we have 157 megs. So it's really 90% savings in the end. Okay, so as I said, this was a real use case which I faced during the last year. And therefore, to conclude the session, I want to share with you some general rules you should keep in mind when trying to reduce your data model size. So first and most important, keep only those columns your users need in the report. I know maybe some of you think that our optimization was just to remove the columns, and basically in 99% of cases, just by removing your unnecessary columns, you will save an unbelievable amount of space. I assure you, definitely. Next, try to optimize column cardinality whenever possible. As we done with the date time columns here, the golden rule here is test, test, test. And if there is a significant benefit from, for example, splitting one column into two or substituting decimal column with two whole number columns, then do it. But also keep in mind that your measures need to be rewritten. That's the thing I mentioned previously. You need to rewrite your measures to handle those structural changes in order to display expected and correct results. So if your table is not so big, or if you have to rewrite, I don't know, hundreds of measures, maybe it's not worth splitting the column. As I said, it depends on your specific scenario, and you should carefully evaluate which solution makes more sense for you. Same as for columns, keep only those rows you need. That means, for example, maybe you don't need to import data from the last 10 years, but only 5 years, as that will also reduce your data model size, obviously. Talk to your users, ask them what they really need before blindly put everything inside your data model. Aggregate your data whenever possible. That means fewer rows, lower cardinality, so all nice things we are aiming to achieve. If you don't need hours, minutes, or seconds level of granularity, then don't import them. Aggregations in Power BI and tabular model in general are very important and wide topic, which is out of the scope of this session. But there are some really awesome resources on the web. I strongly recommend the blog series on creative aggregations by Phil Simark on his personal blog. Avoid using calculated columns whenever possible, since they are not being optimally compressed. Instead, try to push all calculations to a data source, like SQL Server database, for example, or perform them using Power Query Editor. Use proper data types. For example, if your data granularity is on a day level, there is really no need to use date time data type. You can freely use date data type and it will be completely fine. Finally, disable auto date time option. As you saw, this will remove a bunch of automatically created date tables in the background. This saving for by disabling auto date time option can be really significant in the big data models which have a lot of date columns. Okay, so guys, looking forward to hearing your questions. In case that there is not enough time to answer all of them, or if I don't know the answer right now, I will ask Adriano to help me collect them, and I will get back to you with the answers, either through my blog or I will find a way to get back to you. And one more thing, sorry, before we proceed with the questions, one last thing from my side. If I may I kindly ask you to fill the survey and leave the feedback for the session. I would really appreciate if you spend a minute or two to fill the survey, since it would help me to understand what was good regarding this session, and even more important, what was less good, so I can improve the session based on your feedback. I will post this link to a survey to a chat here. And thanks in advance for filling the survey. Okay, so looking forward to hearing questions. I see a question from Christian. Using the explicit SQL statement does break the query folding. I know. Yeah, exactly. Yeah, but if you use, sorry. Yeah, I forgot to do this. Okay, I think.
All right, folks, and
Okay.
yes, I can't see your camera yet. There we go. Great. All right, folks, and outstanding presentation here from Nicola.
I see question from Christian regarding explicit SQL statement and it breaks query folding. That's true, but then try to push all calculations and at one step. So don't do, writing T-SQL statement, then performing some additional calculations. That will definitely break the query folding. But if you put all calculations, all transformations in one step, then it will not break query folding. So it will, the Power BI engine will go just once to a SQL Server to get all necessary data and populate your data model. So if you put everything in one step, that will not break the query folding. Thanks, Fernando. Great. I'm really glad that you like it. Thanks, Chuck.
Folks, you like the presentation? Remember, like, drop a comment on the comment box just below, and subscribe to the channel. All right, Chuck, also thank you very much for the support, everybody here. Any additional questions there, folks? Really awesome presentation here by Nicola. He covered a lot of terrain here regarding identifying the issues and step by step on how to reduce the data size model, but also how to look at what it is, how to monitor as you're stepping through each of the steps. And as you saw, he moved from 771 megabytes file, PBIX file, to one that is less than 161 megabytes. That is just like totally impressive there. Feel free to drop a question here in the comments here, folks.
Answer to Gina's question for query folding, there are some really good resources on Microsoft Learn platform. And for query folding, you can also check Chris Webb's blog. Also, my colleague Nicky van Frankhoven, sorry if I didn't pronounce his last name correctly, the Dutch guy, he also has a nice presentation on query folding. So maybe I can find and put the links, or you can Google it for this. But Chris Webb's blog is fantastic resource for query folding. And the Microsoft Learn platform also has a dedicated part only for query folding.
We have here, thank you, Christian. Can you? So it's a question to you, Nicola, asking to please place the survey question in the Chat
I
here.
put
Great
it.
point.
I put it as a shortened URL and as a full URL. So I'm not sure it should work. I'm not sure if it works. Let me check. It should work. I think. Could anyone fill the survey? Yeah, query challenge from Alex Powers. Thanks, Christian, for reminding me. Yeah, that's perfect. Also, thanks for this. You're welcome, Gina. Glad that you like it. SKC. Just to clarify, cardinality is basically the uniqueness of the value. Correct? Exactly. That's it. So number of distinct values within the column.
Any additional questions there, folks? Take advantage of, you have Nicola right now. Don't delay. Drop a question here. And remember, like the video here, folks. Support the channel. Also, look forward to see you on our next presentation, which will be on, so mark your calendar. Our next presentation will be on Tuesday, October 13th. All right, mark here. Go to the user group, and for that, you can just check out the link below. It's in our comments section.
I'm not sure why it doesn't work. Maybe I didn't do something. I set the option anyone with the link can respond. So really don't have idea why it doesn't work. Sorry about that, guys.
Ivan just said that he does not see the survey link. Put it back up. Let me give it a quick try. Let's see if I can get that for you, Nicola, for the survey. Or can you share the link here via, on Teams?
Just put the complete link, complete URL. So not bit, just full URL.
All right. Let's give it a try here. All right, I do see it, folks.
Yeah, I pasted it on YouTube chat. I'm not sure why are you not seeing it. In the meantime, if there are any other questions, feel free.
All right,
Yeah,
folks.
that's it.
Take a look here at the chat. I just posted the link there. It may be.
Thank you, Adriano. Thanks.
You're welcome. It may be some type of shortening. Let me also see if you can quickly create a short link for it.
I can send you also on Teams because I already created shortened this one. Adriano is the king. His link works. Thanks again, Adriano. Thanks. Appreciate it.
All right, folks, I have just pasted the link in the live chat box. Check it out. Let us know.
Any other questions? Just
All right, Christian.
feel free to ask.
Oh, sorry. Which one is it working? You tried the short link here, Christian? All right, Ivan. Thanks for the feedback. All right. Outstanding. Good to hear. Both links are working. Folks, thank you very much. Anything else you would like to add here, Nicola?
Just to once more. Let me just once more share my screen shortly. So yeah, before I wish you a nice rest of the day, just wanted to thank you for attending the session. Hope that you enjoyed it and got some better understanding of what is going on behind the scenes in Power BI. And I also hope that you will now more appreciate the hard work which Vertipack performs in order to make our Power BI reports lightning fast. So I also believe that while watching my demo, you've got inspiration to optimize your own Power BI data models. As I already said, we are all facing similar issues in our day-to-day work. So trust me, it's not complicated. Just simply follow the rules from the session summary, and I assure you that your models would be much better fit for your reports. And thanks again for having me, Adriano. Thank you all from my side. Hope to see you soon again.
Absolutely. And Nicola, can you swap to your camera here? Folks, everyone, thank you very much. And remember, check out the comment section below. You will see the South Florida Power BI user group link. Register to the user group. Stay up to date to our next presentation, as I mentioned to you there. And if you have any follow-up questions, also go to the user group and drop a question over there. Just send me a message. We'll be able to get that. And all the attendees, thank you very much for taking the time, be present here with us, join and contribute to the user group community. Also to Nicola for making the time for the preparation, delivery, and test for this presentation. It was awesome, a lot of great information to be able to take this and literally just start applying. If you forget anything, remember, just come back here, go to a section that you felt was worth, and just see it again. Any more questions there? Thank you all, and remember to thank us by a like. And Nicola, thank you very much again. Anything else you'd like to add today?
No, just all the best to all of you guys, and stay safe and have a nice rest of the day here in South Florida. I will go to sleep soon.
All right, let me move here. And folks, thank you very much. We are going to end here. We really appreciate your help, your time and attention. Have a great day, a great night there for you all. Be well, stay safe. Look forward to see you, on October 13th. And if you are into Microsoft data and AI technologies, just follow up with us. We have the Microsoft Data and AI user group as well. All right. You all take care. Have a great one. Thank you, Nicola. Thank you all for attending. And goodbye.
Thank you, Adriano. Thanks for having me. Thanks for the invitation.
All right. Thank you, man. Take care.
Yeah, you too. Have a nice day.
All right. Mr. Nicola, we're finished here.